define is to give definition of the physical quantity you are asked to define. Mark for define usually is 2 marks. When the question says define, you are not expected to say all you know about that physical quantity, but you are just expected to say what that quantity is. That's all. It's just 2 marks. Let me give you an example. A question like define velocity. If you are asked to define velocity, what you are expected to say is velocity can be defined as the time rate of change of displacement. Time rate of change of displacement. What candidates used to do in the past is when they're supposed to define, they will start explaining. By the end of the day, there will be no mark allocated. No mark will be given to extra points given by the candidate, because the mark for definition is usually 2, no extra. So, and if you have defined, you get your 2 marks, you are wasting time to write some other things about that. The time you ought to have used to write some other, to answer some other questions. So, information. So definition, additional information, that is how the answer explained. Even when you are asked to explain under part 1, you are not expected to write pages. But thank God the way the question is framed this time around, they give limited space. Unlike in the past, you are given as many as possible strips, booklet to write. Even somebody that is writing jargons can ask for more paper, wasting his or her time writing what will not fetch any mark to him. So, but these days, you already narrowed to the limited numbers of lines you are expected to answer. So when I say explain, what is expected of you is to define and give at least 1 additional information. Let me say at most 2. Don't give more than 2 where you have to explain. Definition and 2 valid information, you are good to go. You get your full mark. Somebody who writes definition and 5 additional information will get the same mark with you that write definition and just 2 additional information. And I want to assure you, the time taken by somebody who had 5 other valid information about that quantity will be more than the time you take to answer your own. And you score the same mark, because the mark for explanation may be 3 or 5, but definition out of it will take 2. The remaining will now be shared. It could be half-half or 1-1. So that's how you have an explanation. Now, if they say define velocity, as I said earlier, the answer to that is velocity is the time rate of change of displacement, or the rate of change of displacement with time. That's what they are expected to give for define velocity. But if the question says explain the term velocity, then you will give definition of velocity and add 2 other information. You are good to go. Why do I answer explain the term velocity? 1, I will say velocity can be defined. That means giving the definition of velocity. Velocity can be defined as the time rate of change of displacement. That answers definition. Additional information can now be velocity is a vector quantity, which is true. You can say the SI unit of velocity is meter per second. That's second additional information. You can say the speed of the present time graph is velocity. I have given 3 valid information. You need not to give the 3 to save your time. In fact, minimum of 1, maximum of 2. When the question says explain, but define, you don't have to give any additional information. Define alone, go to the next question. explain, give definition, and at least one additional information, at most two. Don't give more than two. Go to the next question. These are things some candidates in the past will do. They waste their time, like I said earlier. At the end of the day, they will not be able to finish the exam. And they will say they couldn't finish. They stop at questions also because they wasted unnecessary time on some other aspect. Probably that's the question they know better. They now want to put everything they know down in that question. So please take note. This is just a reminder. I have taught you maybe second class when the program started. But I'm trying to remind you, being the last theory class, so that you put it into practice, and when you get to the exam, the observations on what you did in the test given to you, some of you have not started using that. I want to appeal to you that anytime a question like this you come in contact with a question like this, you answer it accordingly. If you actually want to make A, that's to explain. Number 3, that one does not need much explanation. You can say list or mention or state. Well, state could be state the law. If you are to define or state the law, is 2 marks. You state it correctly. List, mention, or label, or give. I will not want to put states here. You can also say give. So, you don't need any explanation. It's just like any other subject. When you have to list properties of weight, 2 properties, you just mention them. It could be 1-1, it could be half-half. You just list them. That's the way we answer that. Then the next is you can come across a question like describe an experiment. When you are asked to describe an experiment, it's not common these days. But in the past you can be asked in the exam to describe an experiment. But these days it's not common. But how do we answer describe? If you want to describe, you write it in a simple tense, as if you are instructing somebody what he or she must do, as if you are telling your younger one, you are commanding him or her to do something. When you are describing an experiment, you start by writing what you are to do, aim. Then after which, you write the aim or title, what you want to do. Then they follow by what are the things you want to put together. That's what we call apparatus. You write the apparatus, what you want to use to do what you want to do. Then you now put it, the next stage is procedure. That is method. You either call it procedure or method in the exam. How do you go about it? Under the procedure, you show the diagram. You show the diagram, how the apparatus will be set, how you expect that person to set the apparatus. I can assure you, if the diagram is workable, you need not to say much before you score your full mark. If you have drawn a workable diagram, you need to say less sentences. You don't have to say many, or you don't need to write paragraphs before you explain, you carry your message, or you make whatever you want to make across to your examiner. So all you need to do is, once you know you cannot draw, that's the next stage we are going to get to anyway. You cannot draw workable diagram. It's better you don't commit yourself. In marking, we call it committal statement. When the wrong diagram is drawn, you already committed yourself. If you are now trying to explain an experiment with wrong diagram, you are not good to go. In other words, if you are not sure of the diagram, it's better you are silent about the diagram. Go on with your explanation. Go on with your description. So you want to describe something. You describe by using simple terms. So you can give example of how do I determine my density? That is, unknown density of an object. Describe how the density of an object can be determined. That's a simple sentence. But when the question like that is asked, what do you have to say? Solution, you write. Title, to determine density of an object. That's title. How do I go by the, after you have written aim to determine title, to determine density of an object, that is the aim. You now write apparatus. The apparatus are what and what you want to use to achieve your aim. No mark will be given, but if you present your case like that, anybody that lay hands on your script will know that this candidate must have been well taught. You write apparatus. They are what you want to use to achieve what you want to achieve. Under the apparatus, you write the objects that you are to determine its density. You need to know the object. 2, you write weight balance. You will use the weight balance to determine the mass. That's second apparatus you want to use. 3, you need water. 4, you need beaker. Then you can say 5, because you are talking of the density of it. You may talk about having thread to suspend the object. So after all these materials have been listed under the apparatus, you now go to next subheading, which is known as procedure. Under procedure, you show the diagram of the object, you show the water in the beaker, then you also show the water you want to use. So thereafter, you show the diagram of weight balance. You already shown all that. You now go to explanation that weigh the mass of the object on the balance. You know, you already showed the balance. You now instruct that weigh, as if you command the person, weigh the object on the weight balance and record the mass as mass O. You already instructed him to weigh it and record the mass as MO. That's step 1. 2, you now say pour water into the beaker. You may not use beaker, you may use air can or displacement can. Displacement can or air can be used. And if you don't use displacement can or air can, you can use beaker. All you need to do is, okay, fill the beaker to the brim with the water. Fill the beaker to the brim with the water. And put the beaker inside a bigger container. That could be a bigger beaker. So, and you filled the smaller one to the brim. You can now say suspend the unknown density, the object. Suspend it with a thread you already have. And gently immerse the object into the fill up beaker. As you gently insert the object into that beaker, definitely the object will displace certain volume of that water, and displaced water will now fall into the bigger container. You know, you put the smaller container beaker inside the bigger one. So as you carefully insert the object into the smaller beaker with water, filled with water, some of the water will be displaced. And to collect the displaced water and measure the volume in another beaker or in a measuring cylinder. If you use measuring cylinder, you must add measuring cylinder to the apparatus you need for the experiment. When the volume is already determined, the volume of displaced water will now be equal to the volume of the object that was in mass. The volume of object that was in mass into the beaker. You have gotten the mass as MO. You have gotten the volume as V0. Volume of the water that was displaced when the object was in mass will now be equal to the volume of object that was in mass that displaced that water. So it means volume of displaced water equals to the volume of the object that displaced it. Am I communicating? That's what everything has to be put in simple terms. Hence, divide the mass of the object MO by the volume of the object V0 to obtain density. You already described the experiment. You don't need to write lengthy or paragraph your word saying. Apparatus is there, procedure, draw the diagram. Then, now put some explanation as I've just said under procedure. Under calculation is when you will put density equals mass all over volume, MO all over V0. That means density is obtained. You can now put down precaution. What precaution have you taken to ensure accurate result? In fact, you will score a full mark for that. That means you have described an experiment without writing lengthy sentence. That's the way we answer describe an experiment in an exam. But like I said earlier, it is not a common question nowadays, but you can come across it in when you get your various higher institutions. You should know how to answer described question. So, number 5, with the aid of a diagram, that's 5. With the aid of a diagram, if you start with the aid of a diagram, explain. With the aid of a diagram, explain. How do we answer this? With the aid of a diagram, explain this. That is very technical. The examiner starts marking from your diagram because the question says, with the aid of a diagram, explain. Your marking starts from the diagram. I said it before. I'm sure you are not hearing this for the first time. For being the last day, you need to be reminded how to answer question tags like this. Yes, if you are to explain with the aid of diagram, you are expected to draw a workable diagram. You are expected to draw a workable diagram. That's the first thing we look for when you are asked to explain with the aid of diagram. The question is, what the candidate draw, is it workable? If yes, we start scoring. How do we know whether it's workable? There may be some principal thing that must be shown correctly. It may be 1, it may be 2. Those 2 or 1 thing must be first of all properly put in the diagram before we start scoring others. Once those either 2 or 1 or 3 of them are not part of the diagram, they said the workability is 0. The whole diagram will be marked 0. And once the diagram is 0, no examiner will take his time or waste his or her time to go through your explanation, because it is believed that your explanation is based on the wrong diagram drawn. And it's a pity. Your explanation may be right, may be correct explanation, but then nobody will take his or her time to go through your explanation because what you drew is not workable. All he or she is going to do is to mark your diagram wrong and comment. The diagram is not workable. So with that, we just mark your explanation 0. that question you already score 0. Am I communicating? Once the diagram drawn, it's not workable. Nobody is going to read your explanation. What is my advice to you? When you are sure of diagram you draw, you already practice diagram very well, and you know how to draw it. Good to go. You draw it. In fact, you score your full mark for drawing that. But when you are not sure, you cannot start recollecting diagram in the exam. Diagram you have not practiced very well. You now want to try to recollect in the exam, and you are now trying to do something. Please don't commit yourself. What you are doing is as good as taking a very sharp knife and you ask them to sharpen it very well again, and now put it in your neck yourself, and you ask somebody to squeeze it on your neck. That's as good as that. When you are very sure that you don't know about the diagram, you are just trying to show something, you now go to explanation. Please don't do that. Leave the diagram. Don't draw anything. Don't mark anything under the space of diagram. Don't put anything down. Go on with your explanation. You are better. It will be taking that time did not permit you to come back to the diagram. You wanted to explain before you come back to the diagram. That's an assumption. So that person will be forced to read through your explanation and score you accordingly. Even without drawing diagram, you will score mark for explanation. That is better than somebody who's just sketch something and now go to explanation he or she know how to do. So you will not get anything under that explanation because diagram above is wrong. It's not workable. How do I know workable diagram? How can my diagram be workable? I told you last class, and I will still mention it. You don't teach diagram, but you practice it. You practice diagram. I can't hold your hand to show you how to draw, even if I draw it on board. But when you see a diagram from your textbook better drawn, you can use the textbook to draw practice diagram when after you have read what you want to read in the day and you are about to sleep. When you have done, you have achieved what you set for the day. You are dozing. You are about to just learn one or two diagrams. Pick your textbook and see. You may not learn the diagram in your school notes or lesson notes because there may be some other thing. Use the diagram you have in the recommended text. It's possible the diagram drawn in your various school or in the lesson here may not be taken by WAEC. It may be faulty. But when you have a recommended text, that may be even the colored picture. Draw that one, put it before you, practice the diagram, draw it as it is drawn in the textbook. Place it before you. If you do that today, tomorrow, next tomorrow, I'm sure gradually you'll be able to draw that diagram offhand better because you've been practicing it every night. When you are drawing, you can never doze. When you are calculating mathematics, you can never do. I told you that before. I don't know how many of you have put it into practice. You have so many diagrams to practice, especially in the topic we are treating. Ray diagrams. You have ray diagrams, and that's where they usually say with the aid of diagram. For instance, I can say with the aid of diagram, explain compound microscope. I can say with the aid of diagram, explain simple microscope. It is when you practice this, you can draw it better. How many of you have started planning diagram in the night here? Raise up your hand. You start when you finish your WAEC. Daddy, no problem. You've been told what to do. Procrastination, we all know it's a sin. I will do later. I will do later. When you finish your WAEC, learn the diagram. Or when you finish your NECO, learn how to draw the diagram. And of course, Jan will not ask you to draw anything. Takeji. You do that in JAMB. God will help you. Now, as I said, that's how we answer with the aid of a diagram. The part that carry most of the marks, the part that carry most of the mark is calculation. Calculation. I have also taught you how calculation is marked. Of course, you can never pick a question under theory that part of it will not be calculation. You have the theory part explained, defined, I've said it above. At least an option, or how do I say, one part could be B, could be C, could be whatever, will have to do with calculation. How do we mark calculation? What must be shown? What are the features that must be seen or shown in your calculation? So as we said, if you are asked to calculate, you come across calculate. So what do we do? Calculation has to do with one, concept of the parameter. Concept has to do with formula. That's the formula. After the concept, the next thing is correct substitution. Correct substitution. I will give you an example of how we do that. After correct substitution, we go on to correct arithmetic. Correct arithmetic. Of course, calculator will do that for you. Then after correct, that's when you go to correct answer with the unit. Correct answer with its unit. That's any calculation that any of these things is omitted or not shown, you lose mark for that. I will give you an example, and I will show 4 or 5 presentations of a candidate, how the candidate responds to that, and I will score it in your presence before I go back to where we stopped last class. Now, under calculation, let's see this. Example 1. What is the work done by the man? What is the work done by the man who or that pushed a load with a force of 150 Newton through a distance of 100 meters in the direction of the force. What is the work done by a man that pushed a load with a force of 150 Newton through a distance of 100 centimeters, or you can say through a distance of 500 centimeters. Please, let's have it like that. Through a distance of 500 centimeters. Through a distance of 500 centimeters. Solution. I will show 4 or 5 different ways, or 4 or 5 solution provided by student. That is, I will show 5 presentation, 5 different presentation, 5 different solution provided by 5. So candidate A, okay, under solution now, you have solution. Candidate A solve this question. Said, okay, A, present the solution. Say, okay, I want to answer this. Said, given that force F equals 150, then distance X 500 centimeters. Then work done. Don't write anything, just look at it. WD equals what? Then set WD equals 150 times 500. And the answer is 0.0057 joules. That's candidate A presenting the solution. Another candidate present force F equals 150, distance X 500 centimeters, work done, WD not known, but work done FX, which is now 150 times 500. 150 times 500 gives you 0.0057 joules. That's candidate B. Candidate C. C presents his own working solution. Force F equals 150 Newton. Then distance X equals 500 centimeter, which is 5 meter. Then work done, WD, don't know. This is WD equals FX 150 times 5, which is equal to 0.57. That's candidate C. Candidate now they have candidate D. Solution. We have force F equals 150 Newton. Then distance X equals 500 centimeter, which is 5 meter. Work done, not known. Work done equals 150 times 5, which is equal to 750 joules. The last candidate before we discuss and we score. That's candidate E. Solution. Present. Force F equals 150. Distance X equals 500 centimeters. Then work done is unknown. We now have This is the work on. Now, let me stop there. We have different ways people present. Now, close your book and look up. How do we mark 5 candidates? This is what they have. When you copy yourself, we always let you know that you may not necessarily be caught when you are in the exam. But when we are marking, we know those that are copied. I have presented 5 different working. And slightly they are not exactly the same. Are they the same? That's the way we know. But if they copy, they will have the same thing. Now how do we score? Let's assume that the mark for this question is 5 marks. Let's see who will score 5. How? Number 1, candidate A. No mark is given today. We start scoring. You are told that the concept must be written. Was there any concept here?
No, sir.
No, sir. Substitution, when there is no formula, we don't even know whether he knows what he's doing. But this is not correct substitution. This is definitely, this candidate is called 0/5. Let's see candidate B. Now, extraction, work done. The concept, very correct, 2 marks. This is 2. This is wrong substitution because this is not SI unit. This is SI unit. Newton is SI unit of force. Centimeter is not SI unit of length. So you cannot multiply SI units of one parameter together with what is not SI unit of another parameter. That is incorrect substitution. You know, I said correct substitution. So this is incorrect. Why is it incorrect? This is Newton, which is the SI unit of 4. This is centimeter, which is not the SI unit of length. They are not correct substitution. So the substitution, okay, substitution in this case is wrong. So you score no marks again from here downward. So you already score 2/5. You ask, is it not the same answer? B got. This one also got. It's not the same answer. But this scores 0. This scores 2/5. Have you gotten it now? Let's see, can they see? Can they see? Yes. C have parameters here. This is 500 centimeter converted to meter, SI unit. No mark is given to that. But mere looking at that, the examiner knows that oh, this candidate is well taught. He or she knows what he's doing. Maya saying this, going through this, this is the concept, which is the formula. It starts, this is 2 marks. Now, correct substitution, that's another 1 mark. Then, you now go to correct arithmetic, 1 mark, and correct this. This is 1 mark for this, 1 mark for the unit. You score the remaining 2 marks. So here now, you can say this candidate score 5/5. Is that taken? Candidate D. Let's see candidate T. This. Is there any formula?
No.
But because it's substituted correctly, he or she can still be pardoned. That he or she knows what he's doing. He's only trying to beat the time by not writing the formula. Because of correct substitution here, this fellow will score both the formula he did not write and the formula he wrote here. He score all 3 here. Okay, I think I should have given you another wrong formula, but correct substitution. Okay, let me use that here. Now, here, we will score the mark for this here 3 and the last. Here there is no unit, so we score 1 mark. And natural fact, the unit is just, penalty is half mark. So you score this place 2 minus half. So you score 4.5 over 5 because there is no unit. This is 2 minus half. You put half here, unit. 2 minus half is 1.5. 1.5 plus 3, that's 4.5. Just because of omitted unit, he loses that half mark. But he scored, despite the fact that there is no formula here, he still scored this. But there is one without formula that he was not given because of the wrong substitution. Score 0 here. No formula here. Wrong substitution is score 0. No formula here. Correct substitution still got 1.5. Can you make the difference? You apply this to any calculation that comes to your way. You have to be very careful. Now that's E. Let's look at E. Now you are giving force 150, distance 500, converted to meter. Yes, as it is. You now have it, and the unit is put. What do you think this fellow will score? Who can tell me what you think this work with this candle will score over 5? Talk. What do you think it will score? Anybody want to lead us? Are you in the class?
5.
You scored him 5. 3. 3. Okay, let's take it from the boy that say 5. Oh yeah. Score. How do you score the 5? Tell us how you score the 5.
He got the formula. You know that he broke the formula down. Then he got this correct substitution. Then the correct answer and the unit.
Okay. That's why you give this candidate 5. Okay. Who first of all say 3? Oh yeah. Score. How do you score your 3?
I score it from because he did the correct substitution, but
You score from where?
the correct substitution and final answer for the formula.
Okay. You score from correct substitution down. You score half. How do you allocate the mark?
It's not correct, like it's not properly placed. And the substitution, you have to go with the concepts and just the units. So that's all.
Okay, you all try. Well, I'm glad and happy to tell you that this candidate will score 0. This candidate will score 0. Do you agree with me?
Yes.
You are not a good student. You are not good student. I said they will score 0. Do you agree with me? You say yes. You don't contest. Why did you score 5 before? Why did you score 3? Do you agree? You should have questioned me.
Okay, the question
You
is
should have questioned me how and why. So I say you agree with me. Now, I will explain because I want to make certain things across to you. Yes, of course, this is correct substitution. This is correct answer with correct unit. But he or she has committed himself here. This is the wrong concept. Mass was not given in the question you are giving. Acceleration was not given in the question. You are having 3 parameters here, M-A-S. You substituted for 2 parameters. You get the answer. So the way we take it is that the wrong, that's what I said earlier. he has or she has committed himself or herself. This is what we call committer error. He has committed. It shows that he did not know. He's only guessing or copy somebody. It would have been better for him or her not to write this. He will get full mark as it is, like candidate. Which candidate? Like candidate D. Yes. He would have gotten it correctly without the formula, correct solution and this, we score and get the mark correctly. But it shows the examiner that he did not actually know the concept, but he just do anyhow and get the answer. And I have told you, physics and mathematics, you don't start marking from the answer upward. But let me even inform you, the formula, the concept is only the physics. That's why the concept take the larger part of the mark. That's the only physics. Every other thing is mathematics. So you cannot, leko walomi obeje physics because you get the answer. We now know that you know the physics. No. The physics, if the physics is wrong, after all, we are marking physics, not mathematics. Please and please, this is very important to learn and put all these things into practice. You still have up to a month before you sit for your WASEC. It's only jam you sit for next month, April. At least before you write WAEC, it will be around early May. Anytime you are solving past question, let this be at the back of your mind that if you are calculating, do I write the formula? Is it the concept? And also let it be in you that henceforth I will always start my calculation with the concept. From the concept. Look at candidate B. If he or she had not written formula, he would have scored 0. But because the formula written correctly, he snatched away 2 marks from the 5 marks. That's the importance of it. So that is what we are trying to make across. Like I said, this candidate will score. Once the concept is wrong here, the examiner will not bother himself or herself to check through every other thing. You are using the wrong concept to solve this. It's as good as saying you are using the wrong equation. The question given to you, and you have to calculate the question given to you. Yes, MA is false. Do you agree with me? Please and please, whatever information you are giving, you are not just giving to keep. Put that in, yes.
Sir, but he wrote the correct units. I'm not going to allow him mathematics.
You don't, like I said earlier, we don't start marking from the final answers. You cannot score units in isolation. You know what I mean by in isolation? The unit is not physics. So although if I say it's not physics, I may be wrong. But when the whole body is rotting, what is the unit all about? We have not marked, and WAEC has not given mark to units alone in any question. What we mark is what I've just told you. Once the concept is wrong, we don't waste time to check through other things. We score 0. We only talk about unit right or wrong when your arithmetic is correct. One step before the other. You know, I told you, you start solving, marking. You start allocating mark from the concept. It's after that you go to the next line. It's after that you go to the next line. So when you now get the answer, that's when you will now say, okay, what of the unit? Is the unit correct? If not, you subtract half mark for wrong or omitted unit. We don't consider unit until we have the final answer correct before you consider is unit there. Is it right unit? Is it wrong unit? After the whole thing is one thing before the other. Do I answer your question? major part of the math to be solved. Just follow the steps. Know what and what we score in calculation. Don't just work your question anyhow. Just put something down. No. And the other ones I've explained to you. If you pick any past question and you read the question, let those things that I said we look for be shown in your presentation. If you do that, it's easy to make A. Very easy to make A. And what I've just said, across all topics, all branches of physics. So that is that. We go back to where we stop on Monday. As you are practicing past question, make sure you've been told what we look for, what they score, you have been told. So any presentation, any solution, make sure those features are shown. Calculation, what we look for, you've been told. Explanation, what we look for, you've been told. Define, definition, you've been told. Were you not told? Ye shall know the truth. That is you. If you want to be set free, that's when it will set you free. Now, we want to go back to where we stopped on Monday. So, and that is still under optics, because the practicals under optics will come on Saturday. Briefly, we want to look at refraction. We look at reflection of light. We look at refraction time per minute. If not, I will explain that briefly, then I'll give it to you on Saturday. We have just 1 hour, as we are told, on Saturday. So, briefly, we stop at effect of retinal propagation of light last class. And you are told that one of the effects is shadow, which was discussed. Another effect is eclipse of sun, it was discussed. Eclipse of moon, discussed. We stop precisely on pinhole camera, and I'll briefly discuss pinhole camera now. You can go. I will only mention some important things about pinhole camera, and I will tell you to go and lay hands on the calculation under it. Mind you, and I will still repeat that. Diagrams under effect of retinal propagation of light. The technicality is you don't have calculation, but diagrams are there. You are advised to practice the diagram. I ask you now, how many of you have started practicing diagram? All hands were down, showing that you have not gotten time to do that. And I've given you the appropriate time to do it. You can do it after you finish your last paper. Go ahead. Go and learn the diagram there. Is that okay? Okay. God will help you. Now, pinhole camera. What is pinhole camera? It's one of the cameras they used in the olden days. Primitive cameras, and you can always construct that if you want to do that at home. You just need light-proof materials. It doesn't matter the shape. The shape may be cylindrical, it may be rectangular, it may be square. Just what you need is a light-proof materials. That you need to drill is tiny. That pinhole, a very tiny hole. That camera gets its name from the size of the hole. Pinhole camera, very tiny hole. You drill a tiny hole to one face. If it is rectangular, you have 6 faces. So drill tiny hole in one of the faces, and opposite that face, you remove the face there and replace the face with translucent material. I told you translucent material last class.
Yes.
Have you forgotten? Yes. So you can always construct your pinhole camera. If you make a rectangular or cylindrical, okay, you can use bonfita tin. You can even use this MIG tin. The tin is also light proof. It could be wooden material, they are light proof. All you need to do is to, if you are using tin is cylindrical, make a hole at the base, very tiny hole. Make a hole here. Cover the other ends with translucent material. You got in your pinhole camera. This is translucent material. If you hold that thing to look at any object, you will see the image of the object fall here. Pinhole camera. Could be cylindrical, it could be rectangular. You can use anything to construct it. Just make sure that what you use is light hole. What do we need to know about the pinhole camera? Number one thing, the length of the camera, be it cylindrical or this, has two names. We call this one, you can call this the length. The length of the camera will be represented by V. You can say length of the camera. Length of the camera is also known as image. Image distance. Length of the camera is also known as image distance. And one thing you must know, it is fixed. Image distance is fixed. Length of camera is fixed. It's not adjustable. You must have that at the back of your mind. Then, the distance between the hole and the object in front of the camera, that's what we refer to as object distance. It's the distance between the hole and this object. We refer to that as U, which is object distance. That one is variable. That object distance is variable. The modern, the sophisticated camera we are using this day, even the one on your phone, you move closer or farther away from the object you want to snap. If you want the picture to be very bold, you will take the camera closer to the object, then the picture will be very bold. The closer you move to the camera, the bigger the picture becomes. That's the image. The farther away you move from the camera, the smaller the image is. That is also applicable to the pinhole camera. That's why we say the object distance is variable, but image distance is fixed. Am I communicating? Good. The essence of the whole you need to know. I'm just picking them point by point so that you can put them together when you read, you understand. Whole must be tiny. Why must it be tiny? Can someone tell me why the whole must be tiny? Who want to contribute why the whole must be tiny? So, well, the essence of having the pinhole, small hole, is to reduce the rays of light that penetrate. The smaller the hole, the smaller the rays of light that enter. Then what is opposite of that? The wider the hole, the more rays that enter. Then what does it do? If you have many rays entering the hole, then images that will be formed will be many. And when we have so many images, overlapping of images will occur. And it is just because many rays of light interfere and form their own images. So instead of a single image, a sharp image, so many images are formed and they overlaps. So where if you're supposed to have just a sharp image here, they overlap. So you can pick a particular image of this object. That's when if the hole is wide, so many rays of light will penetrate through to form image. Overlapping image will now cause the image to be blurred. For you can now put it in a simple sentence. The smaller the hole, the sharper the image form. The hole, the what? The sharper the what is opposite? The wider the hole, the more blurred the image becomes. And what causes that? I've explained that. What we need to guide against here is two things are fixed here. Please take note. One, the height of the object. Height of the object, this is HO. HO is a fixed parameter. It doesn't change. If I stand in front of the camera, my height is my height. Whatever feet I measured, the cameraman may move closer to me, may move further away, my height is still my height. But the height or the size of image in the camera varies. The object height fixed, the image height varies. You know, we said the closer you move to the camera, the bigger the image become. The farther away you move from the camera, the smaller the image become. That means the size of the image changes depending on the distance of object to the camera. But the height of object does not change, it remains the same. These are technicalities you must know in solving calculation. Height of object is height of, it doesn't change. And remember I've said the image distance is constant, it does not change, but the object distance changes. Okay, now if I were you, I will now pick, okay, so you pair it, object distance varies, object height is constant, image distance varies, image height. So you already gotten everything about the Pinot camera, and you know the size of the hole, the tiny, how it affects. Everything about camera is summarized. The next thing is to go into the calculation. So magnification under Pinot camera. Magnification can be V all over U. That's 1. Image distance all over object distance gives magnification. Image distance all over object distance gives magnification. That's 1. Under Pinot camera, you can have simple calculation under it. Similarly, you can also say magnification is given by image height all over object height. This is another expression that gives the magnification of Pinot camera. The two equations can be equated together. That's another thing. You can also say therefore V all over U equals HI all over HO. That is the third expression when equation 1 is equated to equation 2. So whatever the examiner wants you to, any calculation that will come under Pinot camera, one of these 3 will solve it. In fact, 1 and 2 is equated in the third one. There is no question under Pinot camera you will come across either in WAEC, NECO or JAM that one of these 3 formulas will not solve. And if you come across questions that you solve under Pinot camera and you cannot solve, you all have the number with you. After now, the theory is WhatsApp number. You can also send the question and your trial to this contact. If you come across a question and you have used any of these things under Pinot camera calculation and you could not get it, send it to that contact and make sure you call so that we know I dropped something, I need explanation or I need solution on it. So simple. Go and learn this, the Pinot camera, what and what. And if I were you, I will go and look for exercise under Pinot camera in your various textbooks and start working on them. So that's all about, that's the only simple area we are simple.
At the point of incidence, online on the same plane.
Okay.
Observer wants to say that angle of incidence must be equal to angle of reflection.
That's good. All these things are simple. I've told you and I'll keep on saying. Reflection says incident ray, reflected ray, and normal at the point of incidence all lie in the same time. Angle of incidence must be equal to angle of. Now, we are going to see that on what we want to do now. But before we do that, at the beginning, you are also taught that reflection we are talking about, there are 2 types of reflection, isn't it? We have regular reflection and irregular reflection. Other names for irregulars are scattered or diffuse reflection. And you are taught that what causes scattered or diffuse reflection is raw surface. When the ray incident on raw surface, then scattered reflection will occur. But that's not the area we are going. We want to examine smooth surface, reflection on smooth surface or smooth surfaces. And a good example of smooth surface is called mirror. I don't know if you have any surface that is smoother than mirror. Have you seen any other surface that is smoother than mirror? I At least for now, I cannot say I have other surface that is smooth, and that's why we give example of smooth surface as mirror. So we want to see reflection that occurs on mirror. So the surfaces is now classified into two. Let's first of all look at mirror surface or surfaces. We classify it into two. The surface of the mirror, the first one is plain mirror, and the second one is spherical mirror, or simple, you can say curved mirror. So we have plain and curved mirror. When you say plain mirror, how do we obtain plain mirror? Plain mirror is obtained from plain glass. You all know glass, abi? Plain glass. A plain glass has two faces, isn't it? Plain glass has two surfaces and is rectangular in shape. If one of the faces is coated, if one of the two faces is coated, then plain mirror is obtained. Do you understand what I mean by that? A glass has two faces. Let this stand for a glass. This is a glass, a plain glass. A plain glass can be turned to mirror by coating one face. If I decide to coat here, this place is coated, it becomes mirror. If I decide to coat this place, it becomes plain mirror. Coating one face of a plain glass turn that glass to plain mirror. So it is now compulsory and it becomes an offense punishable under the law if you want to show a plain mirror in faces. If you just draw a line like this, that's what I say workability. If you have to show ray diagram involving plain mirror and the candidate just draw a line like this, they will circle this and call you zero. This cannot stand for mirror. It means mirror is omitted, and without mirror, that diagram is incomplete. If you want to use the correct symbol, use correct symbol. So you may not need to label it. This is a conventional symbol of a plain mirror. This is what we use to show the plain mirror. So please, anytime you have to show a mirror, it must be like this. Now, the second one, we have curved mirror. There are two types of curved mirror. We have two types of curved mirror. They are spherical mirror, curved mirror, and we have parabolic mirror. Spherical mirror and parabolic mirror. Let me take it off from parabolic mirror. It was a mirror we see at the headlamp of our cars that bends like this. If you see a car parked, you will see some shiny surfaces surrounding the bulb. It may be like the one coming out, the headlamp. You have some shiny surfaces that surround the bulb inside. What surround the bulb inside is called parabolic mirror. Parabolic mirror surround the bulb. So the shape or the symbol of parabolic mirror is this. You have it like this, then coated, you coat the back like this. This is the curved mirror. Which side is coated? This is the symbol of parabolic mirror. And in the headlamp, you just fit a bulb here. That's how the bulb is. And this place may be covered with the glass, the headlamp of it. This is what we call parabolic, not complete diagram like this. Curve, the symbol of parabolic mirror is this. So that is that. The spherical mirror is further divided into two. I will round it up and continue from there on Saturday. We have concave mirror and convex mirror. The concave mirror is also known as concave mirror or converging mirror. Concave mirror or converging mirror. Then we have convex mirror, which is also known as diverging mirror. Concave mirror has the shape, the symbol of just like bracket like this. It is called cut. It is called C-U-T, cut from a spherical shape. An arc, sorry sir, an arc is cut here, it becomes an arc like this. Cut from the sphere, a sphere of glass. It depends on which side you coat. If the outside one is coated, then you have concave mirror. If the inner surface is coated, you have convex mirror. Chest in type of mirror is called concave mirror. Chest out type of mirror, if this place is coated now, then you already made convex mirror. But if the inner outside is coated like this, you make concave mirror. This is convex, this is concave. Then the center of the sphere from which it is cut will now be referred to as center of curvature. The distance here will be called principal axis. We discussed that on Saturday, time permit, then we show you the ray diagram of it. But I will appreciate you if you can read this again Saturday, because we don't have more time on Saturday. So we meet you on Saturday. Thank you.
Thank you.